Good afternoon. Hello again. We are in the next cycle of the webinars. This time it will be about the FanSets. And as you maybe remember, the last webinar we were talking about the hex wall, and the idea of this hex wall was something like the smaller counterflow heat exchangers placed in the one casing to have it ready for the bigger air volumes. So here the idea is the same. We have just 1, 2, 3, 4 sizes of the impeller diameters, and then we intend also to use those impellers for the bigger air volumes up to 18,000 cubic meters per hour. And how will it work? So just small information about this will be in this webinar. So generally, as you know, the fan is designed to move the air with a given air volume and given pressure. So this will help to have a high efficiency, and also thanks to the drive always was the problem for the fan, because earlier everybody were using the belt-driven fans, so there were some losses on the transmission from the motor to the impeller shaft. There were losses on the drive, and then pulleys and belt, of course. Now everybody are switching to a higher efficiency. They would like to have a high efficiency drive, so the losses will be much lower than in the previous design. And then, of course, instead of normal AC motors, everybody are starting to using EC motors, which are with much higher efficiency. And what we suggest to use, instead of the one big, very big fan with a big motor, and usually for the higher capacity motors like, I don't know, 11 kilowatts, 15 kilowatts, or 22 kilowatts, usually if somebody would like to have a variable speed, then the frequency converter to drive it is very, very expensive. And then also if they would like to use, instead of AC, some kind of the EC motors, there is a big price increase, huge price increase from around 1.1 kilowatt, 1.5 kilowatt for the higher outputs. So then the EC motors are very expensive, and the payback cost, of course, during the operation of that kind of the motor and drive is much, much longer than it could be when the investment costs would be much lower. So what is in our fans? We have a backward impellers, which give much smooth operation of the fan in characteristics. Then individual fans can be arranged in some 1 row, 2 row, or 3 row installed in the diaphragm of the air handling units, and then it could be connected to each other, and then controlled by the one controller. All of the fans could be used. In that kind of the solution, of course, we have a very high efficiency, higher than the normal. Then, of course, the installation length inside the air handling unit is much shorter, because the fan wall is very short. We don't need some frame for the belt, or even without the belts. The big capacity motors are much, much bigger, so required also a bigger space. After all, on the suction side, we need some space to equalize the airstream, so that, for example, if before the suction side is the heat exchanger, in order to get the whole operational surface of the heat exchanger, there must be certain distance of that kind of the big fans. In the smaller fan, this distance could be much, much lower. And of course, we are saving the length of the units, and of course, cost of the units and space necessary, and all other costs related to it when the air handling unit is very long. So if we look at those small diagrams, we can see that the motors which we have, the EC motors, are with a very high efficiency, around something between IE3, IE4. So these are the highest efficiency motors. Of course, when we have the backward curve impeller fans, the optimum size is on the left diagram we can see, and it is more stable across these changes than the forward curve fan operator, which can go to the different point of the operation, so it can cause also some problems. What are some benefits and the features? Of course, if the impeller is smaller, then all sizes of the air handling units along the air handling units is smaller. Then the flow through the air handling units is much more equal, and there is no some peak with the very high speed and then the area with the very low speed or almost no speed inside the air handling units. And then we can save, of course, the cost, because that kind, as I mentioned in the beginning, that kind of the smaller EC motors are much cheaper than the bigger EC motors. So if we take a few of them, it will be even cheaper than one big EC motors, because then for the EC motors you need also bigger controller, and the controller are expensive, and so on and so on. So that kind of the solution is much better. Then we can have some increased redundancy, because if one, for example, one motor fail, and then the rest of the 5 motors, if there were 6 motors used in the array, so then the other motors can slightly increase the RPM by the controller and keep the air volume on the same level. You just need to close the suction side of this non-working fan, and then everything will be fine. And then you have a time to change the impeller, and of course exchange is much easier, because the size of the fan is very small, so it's much easier to create this smaller fan than the one big fan. Then usually you need to have a support, because there is a very heavy motor. You need to organize and be prepared for this exchange, and then of course the handling unit will be out of service for quite a long time, some hours. In this case we just need to unscrew 4 screws, and there are regarding the electric connection, there are also with some Molex plugs, so it's very easy to exchange it. Of course, the transport of such a small units is much easier than the big units, and this is much easier to handle, especially on the site where you need to exchange it, but also during the installation of the air handling unit is much easier. And of course, backward impeller has a higher efficiency than the forward blade impeller, so we have a lower power consumption. And then due to this Modbus and the 0-10 volt signals, which can control the RPM of the fan, it's much easier to control the whole system. As I mentioned, we have some sizes of the fans, starting from 190, then 225, 250, and 315. It is the nominal diameter of the impeller. And the motors which we use for the smaller fan is just 0.17 kilowatts. And for the other ones we have 0.37, 0.75, and 1.5 kilowatts. And thanks to it, we can have very nice air volume. And then if we put it, as I mentioned, in a fan array system, so we can deliver you, if you give us your inside air handling unit dimension, we can deliver it in the installed diaphragm. You just slide it in, and it is ready for the operations. So that's why we think it's a smart solution, costs you less money, less investment, quicker installation, and a better redundancy in the operation of your customer. And of course, thanks to this controller, if you can check actively the air volume, of course, you can modulate it. And then it could be constant air volume, so if the filter became dirty, you can slightly increase to keep the same air volume of the air. I mean, increase the RPM to get the higher pressure. And also, if you need, for a different application, if you need a variable air volume, you can also modulate it and change the speed. So fans itself has around 72% efficiency. and the motor around 84% of the efficiency. And the air volume for this single fan solution, if somebody would like to install single, it's from around 900 cubic meters per hour up to more than 3,300 cubic meters per hour. And of course, those data and the pressure drop, which we are showing on the table, are there for the optimum working area when you have the highest efficiency. Of course, you can have a higher pressure drops and higher static pressure, to have it. Then, of course, the efficiency will be a bit lower because it will not be working in the optimum, maximum operating, let's say, area. So that's the idea which we have, and as you know, somebody else also are introducing this and using those fan array systems. So we think it's a good solution for the future, saving time, saving money, saving installation cost, and give some benefits. So that would be all for this short webinar about the fan array system which we are introducing. So welcome you to Swiss Rotors website. You can see the solution. If you need some additional technical information with the more details, we can give you some additional information. Just send us email and we'll be more than happy to reply to your inquiry. So thank you very much. I hope it is just very small information to give you about the idea of the fan array systems. And we will be preparing the next webinar for the next group of our products. Thank you very much and have a good afternoon.